everybody who is watching this fantastic video. My name is Olenjolaim TAYAI from beautiful, fantastic country that's called United Republic of Tanzania. I would like to take this chance to welcome you onto our fantastic session 01, which is session 1 of the topic called the introduction, called the carbon. Okay, so before I begin the sessions, I would like just to give you a short introductions. I would like to welcome you onto Tanzania Online Ordinary Secondary School. It's online platforms or online schools when we teach students by using the digital technology and through the internet. So basically, we want to prepare the community, or just we want to prepare the community of Tanzanians, or even of our students, who will be taking the classroom instructions and solve real-world problems. So we do prepare, we do teach science subjects and the mathematics, and then we transfer this knowledge into millions of the students over the internet, over the internet. So we have 3 departments in these online schools. The first department is basic mathematics, where we teach 4 subjects for the basic mathematics Form 1, Form 2, Form 3, and Form 4. And also we have another department of physics, where we teach physics Form 1, Form 2, Form 3, and Form 4. And also now, today, we'll be in departments of chemistry, where we teach chemistry for Form 1, Form 2, Form 3, and Form 4, or class 9, 10, 11, and 12. So the subject is chemistry, the class is for the Form 4 or class 12 in other countries. And then the topic of the day is called the carbon. Say carbon. So this is an interesting topic. This is chapter 5. According to the syllabus of United Republic of Tanzania, a student has to learn 10 topics or chapters during the education of the Form 4. So this is the chapter 5. So it means just like we are done, we've learned 4 chapters, and then this is the 5th chapter. So that's why I wrote that chapter or topic 5. Possibly in your country that you are watching, because this material are useful in any African country, in America, in Europe, in Asia, even in Australia, in any country. That because carbons, when you learn about carbons, first of all, carbon is not discovered in Tanzania. So it's a discovery of ancient scientists or ancient chemists who did a lot of research and a lot of investigation. So this is the knowledge which actually that everybody has to know worldwide. However, that will be using the syllabus of United Republic of Tanzania, but the content are useful in any syllabus or to any students who is around the world. So this program is for the serious students. We are well prepared on this, and we are ready to pour out and to use different teaching aids and different teaching techniques. So we like to ask you who is a serious student. Now it's a time we want to impact your life, to take you from one point to another point. So make sure that you have your exercise book, you have your pen, you have your pencil for the drawing, you have your ruler, and you have all the materials and even the fresh mindset when you are taking this class. So I don't want to waste much of your time. Now let us go to the class, or it means to the program. So in this chapter 5, which means about carbon, before even we begin, because the session, this is introductions of carbon, we like to do just introduction of carbon. We'll have some other sessions again on top of this one, session 2 and 3 and 4, when we get into too much details of carbon. So we say that the first thing that we like just to introduce for you, we like to give you contents that we are going to cover. Contents or topics, right? No, yes, we say that contents or subtopics. You can call them contents or subtopics of this topic, which is called the carbon. What should you expect when you'll be learning the concepts of carbon with me? So there are some few contents that we have to cover. The first one is, we call it 5.1, because this is the 5th chapter. We call it introduction. Say introduction. Introduction of carbon. First of all, we will introduce to you what the meaning of carbon. And then the second one, we say that he will be teaching you about allotrops. Say allotrops. So we'll be teaching you about allotrops of carbon. Right? Allotrops of carbon. Then the sixth one, we say that he will be teaching you about the third one, the third concept that we are going to teach you, allotrops of carbon, and then we'll be teaching you the first allotrop of carbon, which is graphite carbon. So graphite carbon will tell you what the means of graphite carbons, what are its properties, what is its structural formula, and then what are the applications or uses of graphite carbon, right? That is 5.3. And then we'll take you into 5.4 when I will teach you about diamond, the second allotropy of carbon, which is called the diamond carbon. So we'll draw its structure, we'll discuss how the covalent bonds has been formed, and then I will teach you the physical properties of diamond carbon, and then we'll differentiate between the graphite and diamond carbon, and then I will mention the applications of diamond carbons in the daily life. So even yourself, if you have a graphite carbon, you can make something interesting, which I would like just to tell you that we have lead pencils. We have graphite pencils that you use to draw them different diagrams, but you don't know that what are the manufacturing material. But through learning the concepts of carbon, you will see that we are using carbon in our daily life. Okay? Then the next subtopic that we will teach you, which is 5.5, is the third main allotrop of carbon, which is called the amorphous. Say amorphous. Amorphous carbon, right? So amorphous carbon, this is a third allotrops. In this topic, we will teach you only 3 allotrops: diamond, graphite, and the amorphous carbon. However, that in some of the references, or some of the books, they used to mention more than 3 allotrops of carbon. But we'll be focusing on those 3, and you have to make sure that you understand them, because it simplify your life. Make sure that you have the reference books that I've mentioned in session 001, in session 00, which it has been written, the general introductions of 40 of chemistry for the form 4. So the video is still in the same YouTube channel. We have a YouTube channel that's called Tanzania Online O-Level Safety School, in square bracket Olenjolaim M. So all the contents and all the videos and all the lectures and all the sessions that we are recording, they are still in this YouTube channel, so you can access them at any time and also anywhere. So get prepared to enjoy the beauty of chemistry. Okay, so amorphous carbon. Then we have again, afterwards I will teach you about the preparations of carbon dioxide. Okay, so we'll teach you about preparation. Say preparation of carbon dioxide. Right? So preparation of carbon dioxide. Right? Preparation of carbon dioxide. And then 5.7, I will teach you about the properties of carbon dioxide. Preparation, how we prepare carbon dioxide. And then so I'll teach you about properties of carbon dioxide. So this is the symbol for the carbon dioxide. So those are the 7 subtopics or concepts that we're going to cover when we'll be learning this topic of carbon. So let me take you on to the first concept, which is introductions of 40 of carbon. And this so now we are starting with 5.1, which is introduction of carbon. Say introductions of carbon. So introduction of carbon is just like a subtitle of lecture or session 1. So the fundamental question that we like to answer, first of all, what is carbon? That is the fundamental question you as a good student, you have to ask yourself. What is carbon? What is carbon? Pause the video for a few seconds, for 30 seconds, and then think yourself, what is the meaning of carbon? What does it mean? Right? And then you can try to write the answer that you have in your mind, and then you come back onto this program and see whether it is right or it's not right. Okay? But I would like also, before even introduce to you the topic of carbon, I would like just to mention some few objectives that a student has to achieve at the end of this one, of this topic. So he said that these are the specific objectives. So these are the specific objectives of 40 of carbon according to the syllabus. And I'd like just to quote, we say that by the end of this topic, we say the student should be able to, one, the student should be able to name the forms in which carbon exists. To name the forms, so you'll be able to name the forms that carbon exists. This means that allotrops of carbons. Then the second specific objective, the student should be able to describe allotropic forms of carbon. To describe the allotropic forms of 40 of carbon. Describes allotropic forms of carbon. Then number 3, the students also should be able to prepare a dry sample. So they should be able to prepare a dry sample of carbon dioxide. Of carbon dioxide in the laboratory. So this you'll do it at your school. You ask the requirements or the required material in preparations of dry carbon dioxide in laboratory. Then the fourth specific objective that has to be met by the students to outline the properties of carbon dioxide. The students should be able to outline the properties of carbon dioxide. This is the symbol. Okay, and then the fifth one, the students also should be able to explain the uses of carbon dioxide. The uses of carbon dioxide. So those are the 5 specific objectives of learning carbon. That's why that the students has to make sure that you learn carbon and you understand. And I'd like just to tell you that in case that you want to understand organic chemistry, it's better if you know about carbons, because you cannot discuss an organic compound which does not contain carbons as a skeletal element. Also, if you want to pursue any combination during your advanced studies, for example, a combination that including chemistry, including or biology, or both of them, then you'll be encountering carbon in many situations. For example, in biochemistry, you'll find that many structural formulas of different biological structures, they also include carbon. Also, you have a topic that called organic chemistry, which is one of the longest, it's the longest topic for advanced studies. We find that the central atom is carbon. However, that in this topic of carbon, we won't discuss about organic compound. We'll be introducing to you about the carbon. So then, in case you have any questions, don't hesitate yourself to ask in the comment section. On your left-hand side, you see the comment section. Ask your questions. Read the questions have been submitted have been asked by other students. submit your homework, and you can interact with me without any kinds of disturbance. So now let us begin with the first concept, which is called the introduction. Also, you can use this telephone number to send your sense giving, right? Introduction of 40 of carbon. Introduction of carbon, right? Introduction of carbon. So the fundamental question, which is question 1, what is carbon? What is carbon? Okay, what is carbon? What is carbon? Pause the video, ask yourself. You've been heard about carbon, right? In Form 2, one of the elements, it's the 6 elements in the periodic table. But what is it? What is carbon? What is hydrogen? What is oxygen? But forget about those. What is carbon? Pause the video, ask yourself that question, answer it, and then continue to watch the video. So according to my finding, I found this interesting definition of carbon. Carbon is a chemical element. What is carbon? Is a chemical element. Carbon is a chemical element. Is a chemical element like what? Like a hydrogen. This is the chemical element like a hydrogen, like oxygen, like hydrogens, like oxygen, like lead, okay, or any other, or any of the, others of the other elements in the periodic table. So so carbon simply is a chemical element, like hydrogen, like oxygen, like lead, or any of the other elements in the periodic table. We know that you know the 20 elements in the periodic table. The first one is hydrogen, the second one is called the helium, the third one is called lithium, the fourth one is called the beryllium, the fifth one is called the boron, the sixth one is called the carbon. So carbon is the element in the group 4, but it's the 6th element in the periodic table, right? And then the next one is nitrogen, that's the 7th element. The 8th element is oxygen, the 9th element is fluorine, the 10th element is neon, the 11th element is sodium, the 12th element is magnesium, etc., etc. So again, we say that before even we learn about carbons, what is, we say that carbon is a 6th element, is a 6th element, is a 6th element in the periodic table. So this is 6th element in the periodic table. That's a piece of information that you have now. Again, carbon is the element, right? So this is the element found in group 4. So this is found in group 4, right? Because it is called tetravalent compound. And the period, we have something that we call the period 2. So it's found in group 4 and also period 2. So let me explain to you. What does it mean? You have to enjoy the beauty of chemistry. Okay? So I will quickly remind you the periodic table that you learned during the education of Form 2. Suppose that this is the periodic table, right? So this is the periodic table, and then you learned it has how many groups? So it has 8 groups, if you do remember it well, right? So this is a simple periodic table. When you start advanced chemistry, then you will learn about advanced periodic table, which contain more than 20 elements. So you should have such kind of expectation. This is group 1 element, this is group 2 element, this is group 3 element, this is group 4 element, this is group 5 element, and then we have group 6 element, and then you have group 8, group 7, excuse me, and this is group 8 element. However, that we have transition element, but at your level, we can teach you, we just mentioned. So this is hydrogen, here we have helium, and then here we have lithium, and then we have the next one is beryllium, then boron, then carbon, right? Then we have nitrogen, oxygen, fluorine, then next is what? Neon. Again, you will have sodium, you will have magnesium, and then you have, just I want to remind you, you have aluminium, and you will have silicon, then you have phosphorus, and then you have sulfur, you have chlorine, and then you have argon. And then here we have potassium, and here we have calcium. So those are the 20 elements that you know. So listen carefully. So this is, as I said, that this is group 1, right? If you forgot, I want to remind you. This is group 2, this is group 3, this is group 4, group 5, group 6, group 7, group 8. So I want to ask you a question. Where is carbon? This is carbon. It's number 6. 1, 2, 3, 4, 5, 6. Right? So it is 6 element. But again, in chemistry, this one, we call it period 1. And this is period 2. And this is period 3, horizontal. And this is period 4. So calcium, it is in group 2, but also it is period 4. It's the elements in period 4. So horizontal arrangement of elements, we call them periods, and vertical arrangements of elements, we call them group. So that's why that we say, here, this is carbon, here it is carbon. It is in group 4. But this is what we call it period 1. This is period 1. And then this is period 2. And this is period 3. And this is period 4. Right? So that's why that we say carbon, it's an element. That's why I said here, carbon is an element, is the 6th element in the periodic table, and also carbon is found in group 4 and period 2. So you see that this is carbon, right? So if we found in the period 2, now if you take carbons, how many elements does it contain in total? It contains 60 electrons, and this it's atomic number, but also this is number of protons. So it contains 60 protons, and contains also 6 electrons. So if you want to write its electronic configuration, we write that this is 2 ratio of 4, right? Because why am I doing this quick review? I know that you covered this stuff in Form 2, and even you are competent more than I can think. But in case of explain, when I will be teaching you about allotops of carbons, we'll touch a little bit about the valence electrons, because this is inner shell and this is the valence shell. So these are inner electrons and these are valence electrons. So the formation, when carbons is extracted, then it has been formed. It's not like a separate elements like you have been writing here, but there is a formations of covalent bond between one carbon and another carbons, because it is a non-metal or non-metallic. So again, just to explain in detail, we say that now the electronic configuration, this is the nucleus of an atom, right, of carbon. Then this is inner shell. How many electrons does it contain? 2 electrons. 1, 2. And then we have the outer shell, right? So the outer shell containing how many electrons? 4. 1, 2, 3, 4. So that's why that carbon now, because contain 4 valence electrons. So remember that in this one, in chemistry, we call it the inner shell, right? And this one, very important, you need it, you have to know about inner shell and outer shell when you'll be taking advanced chemistry, especially in general chemistry. And this one is called the Valency Shell. So Valency Shell. This also is called inner or core shell, right? Core shell. And this one, for example, that this one are called the Valency electron. So these are valence electron of carbon. But this one is called the core or inner electron. So it's better for you who is a chemist and love chemistry to know about that piece of 40 of information. Okay? So, the next question I want to challenge you. Is carbon a metal or a non-metal? And why? So you have to know what it means of metal and what it means of 40 of non-metal. Okay, pause the video, ask yourself, is a carbon a metal or non-metal? You know that if you do remember what you've been told, we used to say that we group this, we call it the periodic table like this. So this we call them metals, and on this side we call them salty non-metals. I want just to remind you, I know you covered this stuff during your Form 2, but it has been a long time, possibly I've forgotten. So I want to simplify my study. So these are metals on left hand side, all the elements on left hand side of this line are metals, and the elements on this side are non-metals. So you see that carbon is 30, so I say carbon is another, is a non-metal, is a non-metal element, right? So carbon is not a metal element. So carbon is a non-metal element. So what does it mean? It means it has all the properties of non-metals. What are the properties of non-metals? One of the properties, they form bond by sharing electrons, which we call it in chemistry covalent bond, right? By sharing electrons. So again, another piece of information that we need as introductions of carbon, we say that carbon also is a tetravalent element. So this we call tetra. Tetra means 4. Tetravalent element. This is the tetravalent element making. So this is the tetravalent element making 4 electrons. Making 4 electrons. Making 4 electrons, right? Making 4 electrons to form covalent, making 4 electrons to form covalent bond. From covalent bond. So carbon is tetravalent element, making 4 electrons to form covalent bond, right? From covalent bond. So what does it mean? Okay? So I'll give you an example. So example of this covalent bond. For example, you can take a compound that's called the methane. We'll learn, I'll teach you when I'll be teaching you about organic chemistry. Say methane. So methane, its molecular formula is carbon and then 4 hydrogens. So that is molecular formula, MF of methane. So when we write this structural formula, this is carbon, so it combines with 1 hydrogen, forming covalent bond, and this one, and this one. So we say that carbon is a tetravalent element making 4 electrons to form covalent bonds. So these are the 4 covalent bonds, right? So it uses 4 electrons. It uses the 4 electrons, which are valence electrons, 1, 2, 3, 4. So it is shared with hydrogens. Remember that the hydrogens contains only 1 electron. So when you draw it, this is the nucleus of hydrogen, and it contains only 1 electron. So for methane, for instance, for methane, you find that it will be sharing. So for methane, for example, if you want to draw this molecular structure of carbon, then this is the nucleus of carbon, and then here it contains 2 electrons, which we call them in electrons, and then outside here it has what? A valence shell. So itself it has 4 electrons, 1, 2, 3, possibly, and even we have the other one here, 4. So these are the 4 electrons of carbon. So when now it is combining with hydrogen, then you find that hydrogens is sharing 1 electron. So carbons providing 1 electrons to the hydrogen and make the hydrogens to be what in octet state, because now it contains, this is the hydrogen shell. So this is carbon, and this is the hydrogen, right? So now hydrogen has reached its octet state because it contains 2 electrons in its valence shell. So that's why that we say that, okay, so this hydrogen now is bringing 1 electrons like this. So now they do share, right? So they do share. So that's why that we say, for example, again, if we have combinations of hydrogen here, also they will be sharing 1 electron. So now carbon contains 6 electrons, while the hydrogens contain 2 electrons. And this one also contains 2 electrons. Again, another electrons that they might share, this is carbon, with this one. So here again, we have another hydrogen atom, and this is the hydrogen atom, okay? And then you have another electron here, which is possibly that it will be shared with an hydrogen atom. So we have a bond like this, right? So this is what? Hydrogen atom. So each hydrogen now, it is in octet state, and then carbon also has reached this octet state because it contains 8 electrons in its valency shell. 1, 2, 3, 4, 5, 6, 7, 8. So both elements, hydrogen, all the hydrogen atom have reached the octet state, and also the carbon itself also it is in octet state because it contains a full number of electrons in its valence shell. So then that's a concept that, because I want to let you know, or I want to make sure that you love chemistry and you understand the subject even if that you don't want to understand. So another piece of information that we need, we say that carbon is the very important, other elements also are very important, but carbon is very important element in science. In science. Very important element in science. So I believe that now you have a general introduction of hydrogen. So, excuse me. I believe that up to this moment you have the general introductions of of carbon. So then now I would like to take you on to different forms of hydrogen atom. And this is the second question for me that I would like to ask you, a good student. What is allotope? That's the question that we have. What is allotope? What is allotope? That's the question that we have. Good. So you say that allotope, say allotope, So you have allotopy and allotops. So what we have written in the concept that we're going to cover is allotops, plural, not allotopy. But we have to understand the meaning of the term allotopy. So allotopy, or in some of the book, they call it allotopism. Allotopism, right? Allotopism, allotopy or allotopism. So simply this we define that is a property. So this is the property, so it's a property of some chemical elements, some chemical elements to existing in two or more different different forms. Two or more different forms. Two or different forms. Okay, two or more different forms in the same physical state. Please let me know in the comment section whether I understand the subject or not. And tell me you are enjoying this program from which school, from which district, from which ward, from which town, which city, which country, which continent. Tell us in the comment section. We'll be very happy to hear from you. Allotopy or allotopism, this is a property. It's not something else, but it's a property of the sum of some chemical elements to exist in two or more different forms in the same physical state. What does it mean? That if example, that means for example that we have, let's say sulfur 1, and this is sulfur 2, right? Sulfur 1, sulfur 2. Those are the, for example, that is a chemical element. But it can exist in two. This sulfate can exist in two or more different forms in the same physical state. No any change of physical state will influence these atoms to have a property or to exist in two or more different forms. Right? So the same physical state, this one will exist in two or more physical forms, this one will exist in two or more physical forms. So that's the meanings of allotopy. Right? We'll give you the few examples of allotopy. Okay? So this is, for example, sulfur, which can exist in different forms. We have the third question. What is allotops? That is allotopy. What is allotopy? Allotops. Ask your neighbor, pause the video, think yourself, try to answer that question yourself, and then you can continue to watch the video to get the right answer. What is allotops? What is allotops? Ask your neighbor, please. Ask yourself, what is allotops? Okay. This is the meaning of allotops. What is allotops? Very interesting question. In this lecture, I'm not going to teach you about allotops, but I would like to build a foundation to you. So allotops are different structural modification of an element. Allotops are different structural modification structural modifications of an element. In which the atoms of the element are bonded in a different manner. So we say that allotops are not allotropy. Allotropy is different from allotops. Allotops are different structural modification of an element, in which the atoms of the elements are bonded in different manner. That means of allotopes of carbon. Why allotropy is a property of the same chemical element to exist in two or more different forms in the same physical state. Allotopes means that are different structural modification of an element in which atoms of the elements are bonded in different manner. Okay, so before I end this session, and you have to join me in session 2, say examples of allotops are for example for elements that exist in allotropic forms. The first one is carbon. The first allotropic elements. Second is oxygen. Third is lead, is tin. This is transition element. The tin is transition element, if I'm not mistaken. Then you have what is sulfur. Say sulfur. You have sulfur. Then you have nitrogen. Nitrogen, we have phosphorus. So those are some of examples of allotropic elements. Carbon can exist in different forms or in different structural modification. Oxygen can experience different structural modification. Tin, similarly. Sulfur, that's the truth. Nitrogen also experience different structural modification. And lastly is the phosphorus. Right? So those are the examples. However, that in this topic we will focus on carbon. So we won't touch in detail about oxygen, tin, sulfur, nitrogen, and phosphorus. Right? Okay? So very important to start them before we took them into practice. So that's all about examples of what allotropic carbons. So nitrogen, phosphorus, sulfur, yeah, that is good. Okay, so this is the end of session 01 or 40 of general introduction of what of carbon, and then the topic is going to be carbon. So I thank God who have been with me during the preparation of this program, and I thank God for you also who have get a chance to watch this program, and may God bless you abundantly. Make sure that you ask any question concern about what I have taught you today in the comment section. Okay? So make sure to use the comment section to ask. It's just like, yeah, so we are trying to welcome you onto the business. So, very interesting business. Make sure that you go through these elements, and then you'll find that at least that these things will be moving forward. So thank you very much for joining me. May God bless you abundantly for that. Also, I'd like also to invite you what we are doing. So I'd like to invite you in session 02, where I'll be teaching you about the allotrops of carbon, and then we'll begin different approach. Right? So that's what we want to promise you. Make sure to join us. You enjoy the beauty of chemistry. Simply, let us end there, but in case you have a young brother or young sister who is pursuing O-level, then there's a lot of contents there that he or she might benefit on them. So, may God bless you. Then see you in the next session. Stay